All right, everybody, DNS Exam 4, problem number 38. I really like this problem because it ties in with something we're doing in geometry right now. And I'm wondering if you guys sniffed out how to do a problem like this. I don't remember seeing one before where they asked you a question about geometric probability, but that's what's going on right here. So we have ourselves the square here, starting at the origin and going to the point 2, 2 in the opposite corner. And then we have a parabola drawn inside of that square completely. And the problem says if a point picked at random from inside the square, what's the probability that the point lies in the region above the parabola? Okay, so what's effectively happening here is they want to know, all right, if we're going to pick something inside the square, we want it to fall inside the square but not underneath the parabola. We want it to be above it. So we're basically looking at this yellow shaded region right over here, and we want to know what's the probability that a point chosen inside the square is now going to fall in that yellow region. So the concept right here that you may have forgotten about from geometric probability back in geometry is that anytime we're talking about probability, in this case we're doing area right here, it's basically this little formula right here. We're trying to take the desired area, the area of the region we want to hit, and divide that by the total possible area that we could potentially hit. Okay, so let's talk about the two of those in tandem right here. First of all, the thing that we know is that the point chosen at random is going to fall somewhere inside the square. So we need to know the total possible area here, and I'm hoping that didn't bother anybody too much. The 2 by 2 square is going to have an area of 4 square units. But the way we find the area of kind of a weird shaded region like this one that we have in yellow right here, for that one, we're going to have to do the total area and subtract the area of a region that we can find. So we're going to find the unshaded region right here. So the area underneath the parabola, let me do it that way right there. And to find area underneath a curve, that is going to be a definite integral here starting at 0 and ending at 2 of the function, the opposite of x squared plus 2x, and we're going to take all of that with respect to x. Now this is a calculator question, so I suppose we could do it that way, but I switched iPads and this one doesn't have my calculator app, so I guess I'm doing this one by hand. Here we go, guys. Antiderivative here is going to be a negative 1/3 x cubed, and then a plus, let's see, that's going to be just an x squared right there. Let me double check my work there. Yeah, that's all good. And we're evaluating all of this from 0 to 2. So let's see what happens here, guys. Plugging in the 2, that's going to get us a negative 8/3, and we're going to add a 4 to that. All right, so that's what we get from plugging in the 2, and the 0 is just going to give us a 0. So, different ways that we could do this right here, but let me think. A 4 is 12/3 minus 8/3. That's going to get us 4/3 for the area now underneath the parabola. So 4/3 square units. What we really need to find next then is the area of the shaded region. And the way that we find a shaded region is we take the area of the entire figure, which is 4, and subtract the area of the unshaded region, which is 4/3. This is interesting. We're kind of running back in circles right here. So doing this one, again, this is 12/3 minus 4/3. That's going to get us 8/3 square units here, and that is going to be the area of the blue portion up above. And so lastly, let's go back to the formula we set up here for a while ago for for probability. The probability of hitting that yellow region over there is going to be the shaded area, which is 8/3, and divide that by the total area, which is going to be 4. And again, you could just dump this in your calculator, but let's check it real quick. This is 8/3 divided by 4 or multiplied by 1/4. And that's going to get us an 8/12, or it looks like it's going to be exactly 2/3 for the probability being above the parabola. Looks like our correct answer for number 38 is going to be B.